just minutes from Strasbourg Airport. An Airbus A320 slams into a mountaintop.
Delta Alpha, your position?
There are survivors.
And I'll panic because I'm going to burn.
But they are still in grave danger. It's bitterly cold, and what they don't realize is that no one knows where they are.
They could be anywhere in there.
Expect this in the jungle or the rainforest, but not in a highly populated area.
Before investigators can begin searching for what caused the crash of Air Inter Flight 148, they must first find the plane. January the 20th, 1992. Air Inter Flight 148 has departed from Lyon, France.
124.905, thank you.
Captain Christian Hequet and First Officer Joël Charubin are experienced pilots with over 12,000 hours of flying time between them. The flight is a short hop between Lyon in central France and the city of Strasbourg in the mountainous Alsace region. The French airline Air Inter caters mostly to business travelers and prides itself on being timely. Crews are motivated to avoid delays, as former Air Inter pilot Gérard Arnoux explains.
We were famous for a very short turnaround. And the faster we flew, the better wages we got.
Have we been flying for 35 minutes yet?
41 minutes.
The crew is flying an Airbus A320, one of the most technologically advanced commercial airplanes in the world. Even before takeoff, the pilots programmed the autopilot to land on a specific runway in Strasbourg. The cockpit of the A320 is also very different from other planes. Instead of analog gauges, the pilots look mostly at digital displays.
Strasbourg, good evening. Runway News 05. Transition level 50. Wind 040 at 18 knots. Visibility 10 kilometers.
A recording from Strasbourg Airport informs the crew of a change in plan. Due to high winds and poor winter weather, they'll have to land on an alternate runway.
05 in service.
Not the one programmed into the autopilot.
05. What sort of wind are they giving us?
18 knots.
18 knots.
Captain Hequet doesn't like the idea of changing runways.
No chance.
He was hoping to use runway 23, an approach that provides the autopilot with a precise navigational fix. The new runway, runway 05, is surrounded by mountainous terrain that can interrupt radio signals sent to the autopilot.
You know, if we go with the runway 05 procedure, we... Oh, no.
Captain Hequet suggests a compromise.
I'm putting back runway 23. Otherwise, I couldn't make the ILS interception.
He'll program the autopilot to fly towards runway 23. But near the airport, the captain will take over the controls and make a visual landing on runway 05.
You're taking 23 then?
Yes!
Ladies and gentlemen, we are commencing our descent. We ask you to please return to your seats.
Nicholas
Thank you.
Skorias is a university graduate student.
It was a quiet day. I was expecting to go to see my girlfriend in Strasbourg, so I was very happy.
Roger 854, proceed to GTQ air level 140, contact Reims. Delta Alpha, Strasbourg.
Yes, we intend to proceed to do an ILS on runway 23, then an indirect for runway 05 after that.
The Strasbourg controller considers the captain's plan.
Delta Alpha.
He warns that there will likely be a delay due to heavy traffic.
Given that we're going to have 3 takeoffs on 05, you risk waiting in a stack at 5,000 feet.
We're not going to mess about like that, descending at full speed. If they had warned us in advance, cripes!
Delta Alpha, Strasbourg.
I hear you.
Aware of the captain's frustration, the controller offers assistance.
If you want, I can take you with the radar to lead you to Andlo at 5,000.
Andlo is a navigational point on the approach to runway 05. It helps pilots align the plane for landing.
Yeah, that's good.
Oh, yeah. Okay, then, turn left to heading 230 degrees.
148.
Turn left to heading 230 degrees.
There you are. That will save you some time.
Since runway 05 doesn't allow for a full autopilot approach, the captain must calculate the angle of descent on his own.
That makes 3.3 degrees.
Donc 3,3, c'est tout à fait normal, oui.
3.3 degrees is a normal flight angle that provides a good slope for landing.
Doucement, la bonne pente, voilà.
Ladies and gentlemen, we are continuing our descent.
The flight from Lyon to Strasbourg was quite short. I think 50 or 45 minutes. Nothing special. It was very natural and very ordinary.
Thank you.
Turn left, steer 90. 090 degrees, Delta Alpha.
The controller talks Flight 148 through the last turn to align the plane with the runway, now 25 kilometers away. Then, First Officer Cherubin notices the plane is slightly off course.
We're headed inside. You're inside there. You should have started with 070.
Yeah,
At least that much.
The controller also notices that the plane is off course.
Air Inter, Delta Alpha.
It has missed aligning itself with Andlo, the runway's electronic guidepost.
Delta Alpha, you're passing to the right of Andlo.
Nevertheless, he authorizes the landing.
Authorized for final approach 05.
Delta Alpha.
The captain initiates the landing sequence.
flaps towards 2.
Flaps towards 2. Flaps at 2.
Gear down.
Ladies and gentlemen, we are going to land in a few minutes.
Heke notices that the plane is traveling too fast, so he extends the speed brakes. They disrupt airflow over the wing, which helps create more drag to slow the plane.
We have to watch our descent.
The approach axis.
The first officer is more concerned with their horizontal position in relation to the runway.
It was 60. Check it out.
Ouais.
But before the crew can adjust their course,
Delta Alpha, your position? Air Inter, Delta Alpha, Strasbourg.
The crash is catastrophic. The A320 has flown into the side of a mountain.
Delta Alpha, your position?
Flight 148 is no longer on radar, nor responding to radio contact. An emergency is declared at Strasbourg Airport.
This is the last hit we got. We were flying about 20 kilometers away from the airport.
Officials need to pinpoint the crash site, but it's not as easy as it might seem. The airport's radar is not recorded. There has been no signal from the plane's emergency beacon, and surprisingly, no one has reported seeing a plane go down.
It could be anywhere in here.
The proposed search area covers more than 20 square kilometers of dense forest just outside Strasbourg. Nicolas Scorias survives the crash of Air Inter Flight 148 with only minor injuries.
I took off my seatbelt, I get up, I tried to find my suitcase in the lockers, but there wasn't any lockers. I realized that I was alive. It was a crash. I saw a fire in front of me, and I panicked because I said to myself, I'm going to burn. I went to the back of the plane, of what remained of the plane. I found some other survivors.
Come on! It's gonna blow!
I was afraid of the explosion. I was panicked.
With the smell of leaking jet fuel in the air, the survivors move away from the burning plane.
We stayed together, waiting for the first aid.
But the wait will be longer than anyone might expect.
The first reaction that we have after the crash was, okay, in half an hour, 1 hour, most, and the worst, okay, the rescue team will be here. And it wasn't here.
1 hour after the crash, rescuers still have no idea where the wreckage lies. Scorias and the others now face a new ordeal. Surviving sub-zero temperatures in a dark and isolated forest. 2.5 hours after Flight 148 disappeared from radar near Strasbourg Airport, the missing plane has still not been located. Amidst growing tension, the French Aviation Bureau, the BEA, sends in its lead investigator, Jean Pariès.
I immediately called my two main investigators, and we organized the GO team, and we got prepared to rush to the site as soon as this site was located somewhere.
The delay feels like an eternity.
A little bit surprisingly long. We can expect this in the jungle or the rainforest, but not exactly in a highly dense populated area like the Strasbourg area.
With no help in sight, Scorias returns to the wreckage to look for more survivors.
I think that some people that die could have survived if the first aid come sooner.
Nearly 1,000 people search for the missing plane. But 3 hours after the crash, there's still no sign of it. Frustrated, Scorias goes looking for help. He stumbles into a TV crew trying to find the crash. But with no wreckage in sight, they react with skepticism.
They didn't expect survivors from an airplane crash.
Hey, you have to believe me!
They didn't believe that I was one of the survivors, but believe me, I was, because my face was black due to the smoke, the kerosene, and so on.
Come on!
The journalists follow him back to the crash site. where they discover 8 other survivors. Finally, the first rescuers arrive. The crash site is located near the top of the 2,500-foot Mont Sainte-Odile, 19 kilometers from the runway.
They found us after 4 hours and 30 minutes. So it was a mess. I was very, very disappointed that at 20 kilometers from Strasbourg, and they couldn't find us.
A total of 87 passengers and crew have died, including the pilot and co-pilot. The survivors begin to tell their stories, but no one reports anything that might explain why the plane crashed.
I don't know what happened. We were landing. I lost all consciousness. We must have hit the trees.
Bob McIntosh, an American NTSB investigator, arrives at the crash site.
The BEA of France recognized the international attention would be on this accident, even though it was a domestic accident. He invited a group of international accident investigators to come and participate.
Welcome to the team.
The first priority for investigators is to retrieve the plane's black boxes.
We have not removed the recorders yet. Good.
With the boxes trapped in the burning tail section, any delay could prove costly.
We're very anxious about the state of the tape inside. Will it be possible to use it? Will we get the critical information we need?
In France, aviation accidents are also investigated by the justice system. Parias and his team are not allowed access to the site until judicial officials secure the black boxes.
I had a visual picture of the gendarme, transport police standing around keeping us away from the wreckage for a while. And we're very suspicious of these international observers.
Maybe we should wait.
Even taking photographs, which was somewhat surprising to us.
In a previous crash, the crash of Air France Flight 296 in 1988, investigators waited 10 days before turning the black boxes over to police. Rumors persisted that these boxes had been tampered with. This time, police are keeping investigators at bay.
I can recall seeing the glowing embers and seeing the flight recorder sitting there and not being able to intervene and say, get that thing cooled down as soon as you can.
After midnight, the boxes are retrieved from the plane and sent for analysis. Investigators can only hope it's not too late.
They was extremely hot. They looked damaged, they looked burned.
In the light of day, investigators get some of their first clues from the crash site itself. They discover why the plane's emergency locator beacon didn't send a signal.
It was actually destroyed by the impact.
The beacon is located inside the cockpit and is designed to start working after a crash. Its failure suggests an unusually forceful impact with the ground.
We had this first feeling that the descent was abnormally steep.
Investigators examine the engines to see if they may have stalled before impact.
If you find the blades curved and a lot of wood sucked inside the engines, then you understand that the engines were working properly.
And that's exactly what they find. The plane clearly had power, yet it plowed steeply into a mountainside without ever sending out a distress signal. Investigators are puzzled. They hope that the box which recorded the plane's flight data will help them solve the mystery.
Those particular recorders had the best survival record of any recorders. They were the top of the line as far as survivability is concerned.
The black box is designed to survive temperatures up to 1100 degrees Celsius for half an hour. The tape recorder inside is protected by a capsule filled with water.
When the recorder heats up, the water turns to steam, absorbing the energy, and actually vents out through a little hole in the crash enclosure.
But when the flight data recorder is opened, investigators make a troubling discovery.
The FDR was totally damaged, impossible to read anything from it.
It was subjected to heat beyond the 30 minutes. The recorder was just never designed to withstand that kind of sustained heat.
And so we were very disappointed.
There's now only one hope for recovering the plane's flight data, a device called a quick access recorder, or QAR. Maintenance workers use the QAR to access the plane's computers, but it also records some flight data. Unlike the black boxes, the QAR is stored near the cockpit.
Quick access recorders are not protected at all. They're up in the front end of the aircraft, typically in the electronics bay. They're generally destroyed just from the impact damage.
Investigators are encouraged to discover that in this case, the QAR has survived. But on closer examination, their optimism turns to frustration.
The last 20 centimeters of the tape were burned and stretched and were damaged to the point that we could not use them into a machine. We couldn't read it.
Investigators are desperate to retrieve the data, so they take a chance on an experimental technique. Known as the garnet technique, a light is shone through a mineral lens made of garnet.
Use a garnet stone to visualize the magnetic pulses that are actually recorded on the tape.
The special lens helps the technicians differentiate between the positive and negative magnetic pulses, which translate as binary digits, or bits.
There's 768 bits per second, so that's a lot of ones and zeros. You have to be very precise in moving the tape under the lens or the garnet to make sure you don't miss a bit or read the same bit twice, you know? So it's difficult.
Analyzing the data is even more painstaking.
It took about a day to read a second of recording. Any additional second recovered could reveal something that would make a difference.
The effort to retrieve all the QAR data could take a month or more. In the meantime, the focus of the investigation shifts to the cockpit voice recorder. It was positioned just above the other black box.
The cockpit voice recorder, which was just inches away, but outside of the ashes, had air passing over it, survived.
Runway 23. Otherwise,
the recording reveals the captain's anxiety early on in the flight.
You're taking 23 then?
Yes!
Investigators know that landing on runway 05 requires what's called a non-precision approach. That means pilots receive electronic guidance only on their horizontal position, left and right. They get no guidance when it comes to altitude.
The non-precision approach is significantly less accurate. Why, it's not really difficult, but they are less comfortable.
05. What sort of wind are they giving us?
The non-precision approach increases the demands on the pilots. Investigators can also hear that the captain had concerns about landing on runway 05.
48, Delta Alpha, you are number 1 with VOR DME runway 05.
Runway 05.
10 nautical. That won't work.
It's a lot of distress over a non-precision approach.
Wondering what can cause such distress, investigators research pilot training at Air Inter. They find that most pilots did not have extensive training making non-precision landings in the new A320.
I think we should have had double the training compared to an older plane.
Investigators asked the airline for detailed records on the pilot's history of runway approaches. They're intrigued by what they discover. Captain Heke had landed at Strasbourg countless times, but he had never landed an A320 there using a non-precision approach.
We're not going to mess around like that descending at full speed.
Clearly, the captain was uneasy about having to execute a landing he had never made before.
I think the captain was worried about making it in a minimum amount of time, and the minimum amount of delay.
Have we been flying for 35 minutes yet?
And the co-pilot was worried about not getting in trouble by offending the captain.
At least that much.
More research into the pilot's work history offers yet another revelation. While the two pilots had flown more than 12,000 hours between them, they were both still relatively new to the highly advanced A320.
It's 05 in service.
The aviation community misunderstood the magnitude of changes brought by the new Airbus A320.
The captain had only 162 hours in the A320, and the co-pilot even less, just 61 hours.
Behind this accident scenario, there's an issue of confidence of the crew in themselves, in the aircraft.
18 knots. No chance.
They were not prepared, really, to fly in this kind of condition.
If they had warned us in advance, cripes!
Investigators conclude that the crew's training was insufficient. But that alone does not explain the crash.
Merde!
Investigators search for other factors in the crash of Flight 148. They review the conversations between the crew and air traffic controllers.
If you want, I can give you radar headings and take you to Anlo at 5,000.
Yeah, that's good.
The radar vector makes flying easier. The captain was happy because it was reducing his workload.
Turn left, steer 90.
With the controller's assistance, this landing should have been very simple. But when investigators reconstruct the plane's trajectory using radar information from various stations around the airport, they discover a shocking error.
The 090 heading started here.
090, 0 degrees, Delta Alpha.
But it won't take them to Anlo. Last radar vector the controller gave was incorrect. It sent them...
Thank you.
...closer to the mountain.
They were, of course, because of following the heading they got from the radar vectoring, they found themselves in this undershoot situation.
You're inside there. You should have started with 070.
Yeah.
Investigators are also troubled by the controller's choice of words when he warned the pilots, incorrectly, that they were headed to the right.
Delta Alpha, you're passing to the right of Anlo.
From the pilot's perspective, the plane was on the left side of the runway, not the right. It could only add to their confusion.
Le contrôleur, en fait, il a fait un...
It was very poor guidance because he didn't employ the usual terminology.
Et il n'a pas utilisé la phraséologie standard.
Investigators recommend that controllers use only compass points when giving directions. Never the words right and left. The controller's mistakes clearly brought the plane closer to the mountain.
Turn left, steer 90. 090.
But once again, investigators feel they don't have the whole story.
It's not something totally abnormal to start a descent from this situation.
Flaps towards 2.
Flaps towards 2.
It's not what you expected to do every day, but it's not outside the tolerance of the concept of this approach.
Gear down.
When investigators study the plane's reconstructed flight path, they discover something more alarming than the plane's horizontal misdirection. As it circled the mountain, the plane inexplicably entered a dangerously steep and rapid descent.
Perhaps 2.5 times the normal rate of descent.
That's lethal at that altitude.
Without the steep descent, they would have cleared the mountain.
If the vertical trajectory had been correct, they would have no problem at all.
Finding the cause of that sudden descent is now key to understanding why 87 people died in one of the most advanced passenger planes on Earth.
Authorized for final approach 05.
The descent was initiated at 1800 hours, 19 minutes and 38 seconds. That
Delta Alpha
is the point of no return.
By studying Flight 148's trajectory, investigators determined that the rapid descent began 60 seconds before the crash.
Delta Alpha.
There is no indication on tape that the descent was deliberate. How it happened and why the crew didn't notice is a mystery.
It should be a no-brainer. Keep track of the altitude.
The cockpit altimeter gives pilots a constant readout of their altitude.
Altimeter, that's a very precise instrument. They become very reliable. They're accurate to within 5 or 10 feet.
Ignoring it would be a major error in flying protocol.
Flaps towards 2.
The recording reveals just one single remark from the crew about their descent.
We have to watch our descent.
It occurred 16 seconds before the crash. The captain had just extended the speed brakes.
The aircraft was accelerating abnormally. The captain started to realize there was something wrong with the descent rate.
But the first officer changed the subject.
The approach axis. We're hitting the axis a half point off.
There. It was 60. Check it out.
He refocused the captain's attention on the lateral situation rather than the vertical situation, which was the main problem, of course. And they both failed to recognize this situation.
I think they were planning that we're going to break out of the clouds so they'd be able to see the runway, and they wouldn't need to do the full instrument approach.
It was 60. Check it out.
But the plane never left the clouds.
There's an old adage in aviation. Rocks have been known to hide out in those clouds.
It now seems clear that the crew was not monitoring their altitude closely enough. But a bigger mystery remains.
We can only guess why.
What caused that deadly descent? After months of work, investigators may finally have the answer. All the available flight data from the damaged quick access recorder has been recovered.
We were very anxious to be able to read as much as we could.
The data confirms that just before the crash, the plane was speeding towards the ground at an extremely high rate, 3,300 feet per minute. It also confirms that the angle of descent was dangerously steep, much greater than the 3.3 degrees selected by the captain.
3 degrees.
That's quite a difference.
Investigators now wonder, did the autopilot malfunction? Did it somehow fail to obey the captain's safe descent angle and send the plane into a deadly nosedive?
But what state was it in before the accident?
Unfortunately, the flight control unit which houses the autopilot is too badly damaged to provide any definitive answers.
We could never demonstrate that this FCU on this aircraft during this flight functioned properly or not.
But then, when he returns to studying the flight data, Paris discovers something that may finally reveal the cause of the crash. He notices a similarity between two key numbers: the plane's vertical speed, 3,300 feet per minute, and the intended flight path angle, 3.3 degrees.
Coincidence?
Paris uses a flight simulator to test a new theory.
Can you show me a descent of 3,300 feet per minute?
He believes that the similarity is no mere coincidence. On the Autopilot, there are two descent modes: flight path angle and vertical speed. But they are both displayed on the same window. So 3,300 is abbreviated to 33.
Now, show me a flight angle of minus 3.3 degrees.
The problem on this aircraft was that the two values were visible on the same window and controlled by the same knob.
3.3 degrees.
Minus 3.3 degrees.
Paris strongly suspects that the confusing display tripped up Captain Hackey.
So it wouldn't be hard to make that mistake, would it?
The confusion is quite easy between the two modes if you don't do it carefully.
If the captain failed to push the mode selector knob, then entering 33 would not have initiated a safe 3.3-degree angle of descent. Instead, it would have put the plane into a deadly rate of descent of 3,300 feet per minute. Two months after the crash, another Air Inter plane enters a dangerously steep descent for the same reason.
The crew only discovered the problem when they broke out of the clouds.
Those pilots also confused the plane's flight path angle with its vertical speed.
They were lucky enough to have a much higher cloud base so they could correct the problem.
Further research reveals an industry-wide problem with the A320.
Many people confuse these modes, especially during training, and many of them fell in the trap even after the training.
Eager to test his new theory, Jean Paris programs a simulator with all the known data from Flight 148.
Okay.
He then inputs the same rate of descent he believes the Air Inter pilots selected. If Paris is correct, the simulation will end with the plane hitting the mountain. But it doesn't.
We're missing something.
Strangely, this didn't lead to a crash. Every approach would overfly this obstacle by a significant margin.
Have we factored in the wind?
We started to work on other alternate hypotheses.
Let's try again, but initiate the turn sooner.
But nothing was really credible.
No matter how hard he tries, Paris cannot simulate the crash. Unable to explain why, he turns to the plane's manufacturer for help.
Thanks for bringing this to my
After
attention.
much research, an Airbus designer comes to Paris with an explanation about a little-known element of the Autopilot's design. In emergency situations where the A320 needs to change direction quickly, the Autopilot is programmed to reverse the plane's direction at twice the normal rate.
The reaction of the Autopilot would be much faster. And these cases were typically when you were descending and asking the Autopilot to climb, or climbing and asking the Autopilot to descend. We immediately went back to the data at the very second at which the descent was commanded by the crew.
Gear down.
Paris discovers a tragic coincidence.
Sadly, we found that at this very second, there was turbulence.
There was an ascent. It's very slight, but there it is.
The momentary turbulence caused the plane to climb slightly.
And this led to a positive 600 feet per minute vertical speed for maybe half a second.
It was during that same half second that the crew commanded the plane to descend.
It was 60, check it out.
The Autopilot read this as an emergency requiring a blazingly fast descent.
That could be it.
Investigators now contemplate a terrible thought. Could a random gust of wind, hitting at exactly the wrong split second, have been the difference between life and death.
Here it comes.
And we got a crash.
Parias's theory explains every aspect of the crash. The crew's confusion with the autopilot display
3.3 degrees
caused the plane to descend dangerously close to the mountain. Turbulence and an obscure safety feature brought it even closer. It was a fatal combination.
It's a fascinating lesson about the random dimension of accidents. Half a second before, half a second later, they wouldn't have the accident.
The discovery of a confusing cockpit display has enormous implications for the entire industry.
The flight instrumentation of aircraft like the DC-10, MD-11s, the 747s and so on, all the Boeing products and all the commuter products that were using that avionics suite had this vulnerability about it.
Investigators now face a daunting question affecting aircraft safety around the world. If the design of the autopilot interface isn't changed, how many more people could die? There's mounting evidence that the design of the autopilot interface on Airbus A320s led the Air Inter pilots to accidentally dial in a dangerous rate of descent.
3.3 degrees.
We felt a need to start the industry to work on this.
The plane's manufacturer, Airbus, responds immediately.
The main change, which was very quickly made, was to change the display window.
With the new design, if a pilot selects a vertical speed of 3,300, the entire 4-digit number is displayed.
So the confusion between an angle and a vertical speed was no longer possible.
For investigators, only one mystery remains. All Airbus A320 jets are designed to be equipped with a safety device known as a Ground Proximity Warning System, or GPWS.
Which is a downward-looking single-purpose radar that tells you how high you are above the ground directly beneath the airplane. And if it gets to be too low, it'll set off a warning.
Pull up, terrain. Pull up.
But Captain Heke
We have to watch our descent.
never received a warning for one very simple reason. His A320 didn't have that alarm.
The first question, of course, was why the aircraft was not equipped.
So it's not part of the minimum equipment list.
The Air Inter management had decided they did not like the false warnings that had been produced by GPWS equipment.
Normally, most planes fly slower than 250 knots when under 10,000 feet, but we flew at 350 knots until the final approach. So at those speeds, GPWS was always giving off false alarms.
Dans ces conditions, parce qu'il générait des fausses alarmes.
This decision, while legal, prevented the pilots from having one last line of defense before crashing into the mountain.
C'est pas possible d'imaginer un instant.
It's impossible to imagine that the pilot wouldn't have pulled up if he'd heard the alarm.
We should have a GPWS on commercial flights in any case, yes. That's an obvious conclusion.
The report will list these causes: flight deck aeronautics.
Investigators conclude that there was no single cause for the crash of Flight 148.
Training, lack of GPWS.
The tragedy involved an ill-fated combination of many different weaknesses in the airline industry.
We made 35 or so recommendations, including pilot training about the ground proximity warning system, and so on.
The recommendations lead to sweeping changes. Pilots must now have more A320 training before getting behind the controls.
One of the two pilots now need to have at least 300 hours on the plane. They estimated that 300 hours were enough.
Another change, the design of a more heat-resistant black box.
The FAA did a test, did some studies, what the thermal characteristics of post-crash fires were, came up with a value of 260 degrees C for 10 hours.
Delta Alpha, your position? Air Inter, Delta Alpha, Strasbourg.
As a result of the Strasbourg crash, the A320 is now a safer plane.
You can only get this change if there is what people perceive to be a good reason. And sadly, a good reason is still an accident.
But improved aviation technology is still no substitute for well-trained, well-prepared pilots.
There's an old axiom in aviation that you taught early on, that never let an airplane take you somewhere that your brain hasn't visited at least 5 minutes ahead of time. This is an excellent example of a flight crew that didn't follow that particular axiom.
Miami Beach, Florida. Sun, sand, and calm blue seas. But when a tourist points his camera towards the sky, he captures a scene of horror. A plane is falling to the sea.
We have a code 4. Repeat, code 4. The plane down in the water.
As soon as I saw this, I realized, I'm like, oh no, this is the Chalk's airplane crashing.
The downed plane is Chalk's Ocean Airways Flight 101, bound for the Bahamas.
Could it have been a collision with an object? Could it have been a fire? Could it have actually been a criminal act? Let's notify the FBI.
The incredibly rare video may hold the answers.
Can you enhance that for me?
An airline renowned for safety has made a fatal error. But it will take investigators hundreds of hours to finally uncover it.
Bingo.
The Port of Miami, December the 19th, 2005. Giant freighters and ocean-going cruise ships are a common sight. But there's another, much smaller craft that's often seen in this port. Chalk's Ocean Airways flies seaplanes in and out of this busy waterway. Today, Flight 101 from Fort Lauderdale is making a brief stopover here on its way to the Bahamas.
Feather propellers.
Check.
Shut down engine number 1.
Shutting down engine number 1.
Chalk's flies to 2 regular destinations, both in the Bahamas. Bimini, where Flight 101 is scheduled to land this afternoon, and Paradise Island.
Ladies and gentlemen, this is your captain speaking.
We're just making a short stopover here in Miami to pick up a couple passengers. We apologize for the delay. We'll be on our way again soon.
How many are we picking up?
Just 2, but they're VIPs.
For a small community like Bimini, Chalk's seaplanes are a lifeline.
And it's just so much easier in the seaplane to get to the North Island where most of the population is than going to the airport down there. So that was the main thing. It was a convenience factor.
Welcome aboard. I see your boarding passes.
Certainly.
Sergio D'Angillicourt is a Bacardi rum executive. He's the great-great-grandson of the company's founder. The family is well known in the local Cuban community for their anti-Castro politics. He and his wife are flying to the Bahamas to buy a yacht.
Passengers settled in?
We're all set.
Good afternoon, folks.
We'd like to welcome you aboard Chalks Ocean Airways Flight 101 to Bimini. Our travel time to Bimini will be 25 minutes.
Hope you enjoy the flight. Let's have the startup checklist, please.
Roger.
Michelle Marks is in command of today's flight. She was promoted to captain earlier this year. First Officer Paul DeSanctis joined the airline 8 months ago.
Starter on.
Starter on.
This is his first flight with Captain Marks.
All clear to taxi?
All clear.
The Grumman Mallard is a twin turboprop design. It has a V-shaped hull and underwing pontoons. It's designed to carry up to 17 passengers. The plane has retractable landing gear, so it can operate on either land or sea.
Gear coming up.
Takeoff in the Mallard, depending on the days, it could be a lot of fun or it could be a real challenge.
Weight and balance check. We're good.
The Miami seaplane base has no control tower. The crew has to keep a lookout for boat traffic as they taxi through one of the busiest ports in the world.
Taking off out of Miami in the shipping channel, it's kind of like trying to take off during rush hour traffic. You've got boat traffic, wave traffic, the wind, the airplane to deal with, and everybody's going different speeds, and you're trying to get up and go and navigate around everybody, so it was always a handful.
Flight 101 will take off from X-44, a seaplane base near a channel known as Government Cut.
Prepare for takeoff.
Roger. Ready to take off.
Both pilots have their hand on the throttles. It's to prevent the captain from inadvertently pulling back if the plane hits a wave.
45 knots. 50 knots.
This is the moment most passengers are paying for, the takeoff. Half speedboat, half plane. It's a unique thrill.
75 knots. 80 knots.
For the pilots, accelerating through the waves is often the most difficult part of the flight.
The airplane itself was really hard to fly as far as on the water, getting onto the step, which was what we call getting on plane. And in rough sea conditions and in rough wave conditions, it could be a real challenge.
But this takeoff goes smoothly. Flight 101 is no longer a boat, it's now a plane en route to Bimini. It's 2:38 in the afternoon. The plane's flight path takes it past South Beach, where sunbathers and surfers are out in force. Just less than a minute into the flight, the Grumman Mallard is climbing through 500 feet, well below the clouds. Then, the plane rolls violently and dives. The pilots barely have time to register what's happening. Their struggles are in vain. By chance, a tourist from New York catches Flight 101's final moments on his camera. 60 seconds after takeoff, the plane slams into the ocean. Lucas Bocanegra is a lifeguard stationed on South Beach near the Chalks Ocean Airways sea lane.
As soon as I saw this, I realized, I'm like, oh no, this is the Chalks airplane crashing.
We have a code 4. Repeat, code 4. The plane down in the water.
This is Lucas. We're launching the jet ski.
The two lifeguards are the first rescuers to go looking for the plane.
We drove as fast as we could to the scene of the accident. There was a lot of things coming through my head. I was nervous, scared. I was kind of full of adrenaline. We wanted to go in and try to rescue as many people as we could, but at the same time, we've never trained for a situation like this. As soon as we turned government cut, those jetty rocks, we noticed that it was very calm, very quiet. It wasn't like the ocean side where it was very rough. There was no waves. It was very, kind of very eerie.
At first, Lucas Bocanegra finds no sign of Flight 101 or any of the passengers.
Little by little, we started seeing debris float up onto the surface of the water. And we saw some chairs, some luggage here and there, and suddenly we noticed it was a body in the water. As soon as we put the body on our jet ski, we realized that from his injuries that there was nothing we could do. From there, it was just try to recover as many bodies, you know, bring them back for their families.
News crews swarmed the beach.
Chalks Flight 101 plummeted into the channel in full view of tourists lining Miami Beach.
Even a fraction of a second, the whole plane was engulfed in flames.
Black smoke and then an explosion. Pure fire in the sky.
It was so surreal, we couldn't believe that we actually witnessed that.
Chopper 4 over the wreckage as Miami Beach Coast Guard look for any survivors.
But the effort is futile.
We retrieved some of the bodies, but we were unable to find anyone that had survived.
All 20 people on board are dead, including pilots Paul DeSanctis and Michelle Marks. The residents of Bimini are devastated by the horrific news.
I was very sad for the crew and the friends that I had lost on the airplane. You never expect an accident to actually happen. And to see that on television like I did, it was very, very sad.
In Washington, senior NTSB investigator Bill English is put on the case.
I was just in my office doing some routine paperwork for something else, and the director stuck his head around the corner and said, "Oh, there's been an accident." And I said, "Well, what is it?" And he mentioned a Grumman mallard. So I immediately knew it had to be Chalks.
Within hours, investigators are at the crash site, where 19 bodies have been recovered. One is still missing.
I was very familiar with Chalks Airways. I'm a seaplane-rated pilot myself, and there is the reputation, the legend of Chalks Airways, the oldest continuously operating airline.
Chalks has a long and rich history. The airline was founded in 1917. During the Prohibition era, passenger lists included notorious rum runners and later Hollywood movie stars. Chalks planes even patrolled for German U-boats during World War II.
The novelty of flying at Chalks, it was just all that history, all the people that have gone, and it was really a great place to work for that.
The Grumman Mallard flying boat that crashed was built in 1947. Chalk's Ocean Airways is the only airline that uses mallards to transport passengers.
They're not really a mainstream type of airplane, and so there's always that nostalgia about them.
Salvage crews find the plane's black box. Investigators send it to the NTSB in Washington. The box promises to reveal critical information about what the pilots were doing in the seconds leading up to the tragic mid-air disaster.
In any investigation, the flight data recorder and the cockpit voice recorder are a great desire. More data, the better. We can always learn something.
But Bill English knows he isn't going to get all the data he wants.
Okay, thanks.
The only recorder on board the Mallard was a cockpit voice recorder, or CVR.
Most airline aircraft have two flight recorders. The flight data recorder, depending on the aircraft, will record all sorts of parameters of the flight: altitude, airspeed, control positions, and so on. The Chalk's airplane was not equipped with a flight data recorder. It did have a cockpit voice recorder.
Though the lack of flight data is a big disappointment, media coverage of the crash gives investigators a very rare piece of evidence.
Authorities revealed that the final seconds of Flight 101 were captured on amateur video. The dramatic footage was shot by a tourist on South Beach.
Let's get a copy of that video. Okay, let's see it.
The video only captured the final seconds of the plane crash, but it confirms eyewitness reports that a wing ripped off in midair.
Can you enhance that for me?
The video showed the wing just after separation from the aircraft, the main part of the aircraft fuselage rolling off in the other direction, and the fire and smoke starting from that.
It was quite startling that the wing would fall off in this plane. It was a beautiful day. The water wasn't rough on the takeoff, and all of a sudden this wing just dropped off. It must have been absolutely devastating.
However, the video can't reveal why the wing came off. Answers to that question may lie at the crash site, where salvage crews are finishing their recovery of the wreckage of Flight 101. The right wing is found separate from the plane, but largely intact.
Wings falling off aircraft, modern day situations, is a very rare, extreme event, and there's only been a few cases of them in the past 20 or 30 years.
In Washington, another type of examination is already underway. At the NTSB lab, technicians are busy analyzing the Mallard's cockpit voice recorder tape.
The cockpit voice recorder, CVR, which does what it sounds like, records the pilots' voices talking to each other or on the microphones.
But the tape is a jumble of voices and sounds. Technicians can't retrieve any useful information.
It turned out that the erase head function, it's just like a tape recorder that most people are familiar with. It didn't erase the old stuff, so every subsequent flight kept getting recorded over and over and over again, and just became a muddled sound, and it wasn't audible to us or useful.
It's another setback.
Okay, let's revisit this again because we're running out of options here.
Investigators have fewer and fewer tools to work with. Bill English considers the possibility that Flight 101 hit turbulence so violent that it tore the plane apart. But the weather on the day of the crash doesn't support that theory. There were no storms that could have caused such severe turbulence. Clearly, something else had torn this plane apart. There's a possibility the Mallard collided with something in the water before takeoff.
Seaplanes don't take off of a conventional runway. They're in water where there can be things like logs or other debris, which could potentially cause structural issues with an aircraft.
But before they can reach a conclusion on that theory, investigators consider some other intriguing evidence. It's an urgent advisory issued by the Federal Aviation Administration, or FAA. It warns that due to a faulty part, the propellers on the Mallard could come off during flight.
You're kidding me.
Something such as a blade separation, losing part of the propeller, could cause a great structural load on the aircraft.
English now has a solid lead, but his team is still missing the evidence they need to prove their case.
The entire island is devastated by the loss of life as investigators searching for answers wait for more wreckage to be pulled from the sea.
In the aftermath of the crash, Chalk's Ocean Airways grounds its remaining fleet of 4 Grumman Mallards. At the NTSB's Miami command post, they're working to identify various plane fragments and other debris from the crash.
We started out with the wing itself that separated the spar, which is the main part of the structure of the wing, and any of the other fracture surfaces, looking for obvious initiation factors.
They carefully examine the propellers, looking for evidence that might confirm suspicions raised by the FAA advisory. But it's another dead end.
We're able to determine all the blades were attached, and the bending that we saw was the expected pattern from proper operation when those blades hit the water.
Once again, they're back to square one.
This is what I want you to look at.
Investigators focus their attention on the fractured wing. They've noticed sooting on parts of it. It's evidence of a very rapid fire.
We want to find anything that could be the initiating factor for the wing separation. Could it have been a collision with an object? Could it have been a fire? Could it have actually been a criminal act?
The burn marks raise a sinister possibility. An explosion. A bomb. This now falls outside the NTSB's area of expertise and authority.
Let's notify the FBI.
The FBI helps us in many of our investigations, and we will utilize some of their experts to rule out terrorism or a criminal act.
If it was a bomb that brought down Flight 101, a likely target would have been one of the 18 passengers.
Thanks for coming in. We're going to need your help on this.
One name stands out on the passenger manifest. Sergio D'Angelicourt.
Welcome aboard. Can I see your boarding passes?
Certainly.
There are rumors on the internet that the crash was an assassination plot and D'Angelicourt was the target. His family made a fortune in pre-Castro Cuba. They were so opposed to Fidel Castro's regime that they had allegedly supported clandestine attempts to overthrow his communist government.
This is your copy? All right, now there's something I want to show you. We can't tell if it's just soot or it's explosive residue.
A bomb will leave chemical traces and distinctive patterns in the torn metal. FBI technicians are specially trained to detect them. The samples from the wreckage will be tested at FBI labs in Quantico, Virginia. Four days after the accident, salvage crews are still bringing in wing fragments found at the crash site.
So we need everything that looks like it come from the right wing. Can we get some light over here? Overstress.
Most of the damage they see is from overstress fractures, areas where the metal was literally ripped apart when the wing tore off.
Here. That's the seam.
When metal is suddenly stressed to the point of breaking, the fracture leaves a very distinctive rough edge. It's easy to distinguish it from fractures that have developed slowly over time.
Cut this from here to here and get it to Clinton, Washington.
As we started to examine the right wing, spar and other components on scene at the Coast Guard station or the seaplane base, this was a visual examination there. We didn't have the sophisticated lab tools that we have at headquarters.
They identify parts to be shipped to the lab in Washington, where they hope closer inspection will reveal exactly what went wrong with the wing.
Hey, Clint. Clint, we're sending you as much of the wing as we have your way. Yeah, okay. Yeah, no, I'm still waiting for that report.
The results from the FBI explosives test come in.
Is that... Oh, yeah?
Yeah.
A mid-air bombing assassination could explain everything. But there is no explosive residue on the wreckage.
Okay, so that rules that out.
Structural failure is now the chief suspect in the downing of Chalk's Flight 101.
Well, that's all that's left. That's tomorrow.
It was obvious the airplane had a catastrophic structural failure. So we needed to find out the cause, the initiating factor of that structural failure.
He needs to know more about the long history of this particular Grumman Mallard.
It's very typical in any accident investigation. We want to look at the maintenance history of an aircraft. For an aircraft that's 60 years old, that's even more so important.
It takes days to comb through the 28 boxes of old records.
We want to make sure that we can develop an entire history of this aircraft, what sort of chronic problems may have shown up in the maintenance of the aircraft, and what types of work had been done on any of the factors that looked likely to be involved.
Clint Cruikshanks is a structures investigator for the NTSB.
When we go into an investigation, we try to go in with a very open mind and look at the wreckage and let it tell the story for what happened. We wanted to look at every piece that broke on the right wing to determine if this was a age-related failure or if it was something that was caused by a structural overload.
As with most aircraft, the Mallard's wings are built from aluminium alloy. The spars run the length of each wing. In between the spars are stringers that give added support. Together, these parts make up the wing box, which also doubles as a fuel tank.
And then the skin is over top of all of that structure to kind of give a smooth aerodynamic look to the wing. All of these together work to carry the flight loads that the wing is designed to carry. Once you compromise one piece of that structure, the ability to carry the normal flight loads has been compromised. Thanks.
Over the years, the wing box had been repaired many times. Chalk's mechanics had patched up areas damaged by corrosion, which is not unusual for an aging aircraft, especially a seaplane.
The fact that they land on water means that their takeoff and landing loads are different than you would have on a land-based airplane. Also, they're always in water, and the corrosive effects of water are going to happen more readily on those airplanes.
But when investigators examine the rest of the Chalk's fleet, they find that the Mallards are in far worse shape than they imagined.
Corrosion repairs. Corrosion. 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 Corrosion repairs. Lots of them.
The accident airplane and the other airplanes in Chalk's fleet were rife with maintenance issues. Corrosion was rampant on all the airplanes. There was evidence of shoddy maintenance practices on all of their other airplanes.
Many of the repairs exhibited extremely poor workmanship in quality, double, triple drilling of holes, excessive grinding of corrosion, scars on the material. And this involved the structural repairs that were made to the aircraft over the past few years.
Cruikshank's attention is drawn to a section of the lower right wing. There is a metal patch called a doubler on the surface of the wing's skin.
A doubler is simply a sheet of metal that goes over top of the skin, and it acts as a load transfer. It acts as a second piece of skin to patch the crack. It's kind of like the patch on a pair of jeans.
This is a big repair job. You sure we don't have anything on this?
It's an intriguing discovery. The patch is located exactly where the wing broke off from the rest of the plane. When he takes a closer look at this section of the wing, Cruikshanks notices the edges are smooth and shiny, totally unlike the rough edges he's been seeing on other debris.
We gotta see what's under this.
This crack is not from overstress. Instead, Cruikshanks suspects it developed over many years as the result of metal fatigue.
Metal fatigue is a process by which any piece of metal, a wing spar or anything, is repetitively loaded and unloaded. You can think of it as bending a paperclip back and forth, and everyone's done this, and after a while, it eventually breaks.
Metal fatigue in the wings is caused by the stress of flight over the lifetime of the aircraft.
In the case of this aircraft, every time it took off, the wing is loaded. That's lift that gets the airplane up into the air. Every time it lands, the wing is now unloaded, and there's no more stress on the wing structure anymore. That's just like bending that paperclip back and forth.
Cruikshanks is eager to find out what's underneath the metal patch.
Okay, let's see what this doubler's hiding.
They find even more metal fatigue. Deep cracks cut across the wing. The extent of the damage is staggering. A crack 40 centimeters long.
Man, oh man.
Investigating further, Cruikshanks makes another disturbing find.
3 machined holes in the skin forward of the leading edge. All 3 appear to be stop drill holes.
The holes indicate that Chalk's mechanics had been trying to stop the crack from spreading further. Years earlier, a mechanic had spotted the crack on the lower surface of the wing. He repaired it by drilling a hole in the path of the crack. It's called a stop drill hole.
The end of a crack, you can see even with the naked eye, is sharp. It comes to a point. That tends to want to develop a crack more. By drilling a hole at the end of the crack, that would spread out the stress, and the idea is to stop the growth of the crack there.
But the stop drill holes didn't work.
An attempt was made to repair that skin on 3 different occasions by stop drilling.
Even as mechanics put in more holes, the crack kept growing.
After the 3rd stop drill, an attempt was made to further repair the wing by attaching doublers on the interior and exterior surface of the skin.
But the doublers didn't work either. The crack on the plane's skin continued to grow. Investigators now know the right wing was damaged long before the day of the accident. What they don't understand is why the crack could not be stopped.
Approved.
But a glimmer of an answer comes when they learn the plane was sending out warning signs of a deeper, more serious problem.
The Chalk's airplane involved in the accident were showing evidence of chronic fuel leaks for a long period of time, for many years.
According to the log, fuel leaks from the right wing were repaired again and again, but they kept happening.
The crews started to notice repeated fuel leaks during standard operations, and we tried to bring it up to the attention of management just for our concerns.
Just 2 days before the crash, it happened again. While doing routine maintenance on the Mallard, a mechanic came across fuel dripping from the right wing.
They always addressed the problem with trying to reseal the fuel tanks or trying to fix whatever problem they thought they had. It always seemed to be a reoccurring issue.
The procedure for plugging a leak was to apply a chemical sealant to the inside of the empty fuel tank. The sealant would take a day to dry. Then the plane could be refueled and returned to service. The leaks should have been a clue that the crack in the wing skin was just the tip of the iceberg. That there was a much more dangerous problem with the wing's interior structure.
Fuel leaks in this particular aircraft are indicative of a problem with the wing structure. In fact, Grumman put out a service bulletin back in 1963 that warned mechanics chronic fuel leaks are an indicator of a structural issue with the aircraft.
Okay, let's see what we got here.
Cruikshanks examines the pieces that make up the right fuel tank.
Some kind of sealant.
He wonders why the fuel leaks persisted in spite of the constant efforts to repair them.
Hand me that scraper, please. Thank you.
Beneath the layers of sealant, he finds his answer.
Bingo.
Cracks in a critical support beam called a Z-stringer. It's the piece that the plane's skin was directly attached to.
All right, will you finish cleaning this off and then get some pictures, okay? Thank you.
Cruikshanks finds evidence that Chalk's mechanics had tried to repair the stringer.
It appears that they did some grinding on the Z-stringer to remove a fatigue crack. However, they never went back in and re-inspected that area.
Instead, they only applied chemical sealant to the area to make it leak-proof, and in the process concealed the damage.
Chalk's made repeated attempts to repair the airplane by stop drilling the wing skin cracks, adding doublers over top of the cracks, but they never addressed the root of the problem, which is the cracked Z-stringer. The reason they couldn't address the Z-stringer is it was covered in fuel tank sealant.
The broken Z-stringer weakened the entire wing. Now, with every takeoff and landing, the plane's skin was absorbing the forces. Over time, the skin began to crack as well. The final outcome was inevitable.
The fatigue cracking reached critical length and the wing separated from the airplane.
investigators conclude that a hidden crack in a key component of the right wing led to the devastating crash of Flight 101.
Go all the way up and down.
Chalk's failure to identify such a serious problem now forces investigators to re-examine the airline's long history. Chalk's Ocean Airways had an image as one of the safest airlines in the world. Despite the age of their fleet, the airline had an outstanding record of safety dating back almost 90 years.
Chalk's safety record was great. They had never lost a passenger in all the years of operation.
Chalk was an old, established company, but it seems to me that somewhere along the line, the management and the quality of the work done had slipped quite a bit from in the past years.
What have you got on the financial state of this company?
Investigators are beginning to suspect that the company's reputation for safety may have been undermined in recent years by money problems.
Financial issues in an airline, especially a small carrier like this, can manifest themselves in many ways. Personnel are sometimes one of the first things to go.
A search of Chalk's financial history uncovers some trouble. In the 1980s, Chalk's went through a string of owners before going bankrupt in 1999. The airline was revived by a Miami businessman, but it kept losing money. Just a few months before the crash, the last attempt to sell the business fell through.
Not doing so well.
It wasn't a secret that we were having financial difficulty. The pilots had taken pay cuts and the captains had taken concessions, and we downsized a lot as far as personnel.
It wasn't just personnel that felt the pinch.
It was difficult for Chalk's to find spare parts and to do some of their repairs. Chalk's had a number of other unflyable aircraft that they owned that they would cannibalize for spare parts.
There were maybe only 50 or 55 aircraft ever built. In that case, the original manufacturer, Grumman, was no longer in production of that aircraft. They no longer supplied parts.
The airline's deteriorating health and the shortage of spare parts had a direct impact on safety.
There's so much regulation and there's so much just necessity to make the airplane fly. It's hard to skimp on maintenance and not impact reliability. And if you don't have reliability, then you're just spiraling downhill.
But no matter how tight the finances were, as a commercial airline, Chalk's should have been closely monitored by the Federal Aviation Administration. In fact, the FAA did assign an inspector to work closely with Chalk's.
The FAA inspector, which is called a principal maintenance inspector, was responsible for the oversight of the maintenance program as carried out by Chalk.
The inspector was aware the plane was suffering from chronic fuel leaks. And yet, inexplicably, he gave Chalk's a clean bill of health just 2 months before the crash.
What was this guy doing?
Investigators are at a loss to explain why the FAA inspector didn't pick up on warning signs the Chalk seaplane was giving off.
The fact that Chalk was an old established carrier, maybe they just accepted, well, there's only 2 or 3 planes, it's a small operation, they only fly during the nice weathers, and they're good old boys over there, they know what they're doing.
In effect, the FAA didn't step back and take a look at that forest for the trees and find out just what's going on in the maintenance program with these Chalk's aircraft.
The FAA may not have found fault with Chalk's, but it turns out that several people very close to the airline did.
But we did talk to this group of pilots who had left Chalk's prior to the accident, and every single one of them did have some story about maintenance aspects on their aircraft, whether it had to do with fuel leaks or other maintenance aspects. They all had some level of concern about the way Chalks was taking care of these very old airplanes.
In fact, the pilots were so concerned that in the year leading up to the crash, many of them met to discuss the problem of declining maintenance.
The captains of the company decided that it would be best for us to get together as a group, discuss the issues that we had to try to get our concerns addressed. One major issue that had happened, we had an elevator cable that had snapped in flight, and the crew luckily was able to get the airplane down using power and different settings and shifting people. But in most scenarios, that would have been an accident in itself. In aviation, there's error chains that they talk about, and you have to just, if you keep compiling one link after another, it's only a matter of time before an accident will occur. And from my point of view, I thought that if they kept going down the same road that they were going down, something could happen.
Eventually, Captain Weber decided he'd seen enough close calls.
My turning point and why I decided to leave Chalks was I just had seen too many things in the recent months, too many mechanical issues that were major issues in my mind, and I had 3 engine failures myself that year, and I had a wife at home that was pregnant. I had lost, I guess, my confidence in the company's ability or the airplane, and I just had had enough.
The NTSB's report on the crash of Flight 101 harshly criticizes the FAA for not detecting growing maintenance and financial problems at Chalks.
Had the maintenance program or the FAA stepped back and said, these aircraft need more than just a one-time fix. They need something much deeper than this, the accident probably would not have happened.
It also uncovers a loophole in the FAA's aging aircraft regulations, which require extra inspections for older planes. But those rules didn't apply to Mallards.
The Grumman Mallard was manufactured in 1947. It only carried 17 passengers, and it was not a transport category airplane. Therefore, it was exempt from these supplemental inspections. What we have here is the FAA has made an aging airplane safety rule, and they've exempted the oldest airplanes in the fleet.
The NTSB recommends that the FAA expand its oversight of aging planes.
When we determine the probable cause of an aircraft, the point is to do this so that similar accidents won't happen again in the future. I think we've used this accident to point towards the industry and the FAA to make sure that they take a look at the overall picture of what's going on at an air carrier.
Flight 101 spelled the end of Chalks Ocean Airways. A few months after the report was released, the airline shut down.
There was a lot of history and a lot of family community involved with the passengers as well as the people in the airline. So to see the whole airline and everything else kind of go down with the airplane is additionally, emotional for everybody that ever worked there or ever loved the airplanes.